Ask him. We are sharing, no, you are sharing a PowerPoint.
Yeah.
Aren't you? Okay, thanks. No, he's presenting.
He's presenting.
Yes, he's presenting.
We are streaming.
We are just sharing everything, okay, but he's presenting.
Yeah.
We are already online, so we're ready to start.
Good. Then I will share my presentation. Takes a little bit of time because of the size of the presentation, I believe.
If you have problem with presentation, you can present us.
I know. You want? Okay, don't worry.
You see my screen? Can you confirm that you see my presentation?
We're just seeing a blank screen, Dr. Musmeci. We're seeing a blank screen so far.
That's a moment.
Yes, okay, yes, it's okay, I think it's going to...
You can present us if you have problem.
Ok, vediamo un po', la prof Lauria, tutto bene, trucco, parrucco. Io voglio il trucco però, make up.
Va bene.
Sempre noi.
Vediamo se c'è.
Okay, yes. Now we can. Perfect.
Very good.
Good. Let's start.
Yes, perfect. It's ready on the screen. Okay. Daniel che cosa mettete qui con l'acqua, quaderno e tutto, ok? Bravi. Guarda che
Yeah, we've passed from Scotland to Italy, as you can see, from Google Earth. And then we jump to Italian Space Agency, close to Rome.
Yeah, I see. So cool. This is presentation.
Then I hope that in future you can organize a visit in person in Rome inside the Italian Space Agency. Then today I will present you some content to show you how much the space sector is changing in the last 60 years. And the title is From Dream to Economy, to underline the fact that indeed the beginning of the space era was pushed by people dreaming to do something quite impossible. Today we have an economy that means private company investing on space, but first of all, a lot of results of the space investment are used today in our everyday life. Then this is just an example of through pictures how much the space technology services are used every day in our life. Solar panels, even medical sector, food production, drones, robots, even artificial intelligence. This just to tell you that I'm working on space since a lot of time, almost 35 years. This myself at the control center of Houston during a space shuttle mission. This was in 1994. This is the last mission I followed as a technical responsible. This is a lander, maybe you are aware of this mission that has been concluded recently. Was a lander going to the moon. On board the lander, there is an Italian payload named Lugre that is a satellite navigation receiver. This photo you can see on the right is taken by the lander. You can see the Earth on the sky of the moon. Then this small circle, all we are inside. The antenna of our receiver is the box you can see, the rectangle pointing the Earth. And the idea was really to test how much we are able to receive GPS and Galileo from the moon. This is a picture that is showing you all the different activities that are ongoing at the Italian Space Agency for human and robotic exploration to go on the moon, but even to prepare ourselves for Mars. That is the final objective. More or less in line with the Artemis program objectives. You can see on the moon there is, first of all, the Lugre payload on the lander named the Blue Ghost. One of the most important activity we are going to design together with the NASA is the multipurpose habitation module, that is a pressurized module on the surface of the moon to accommodate astronauts of Artemis mission when they are there in the next missions. This is a beautiful picture taken by the lander before to land on the moon. This is the logo of our specific payload. By the way, we were even able to catch signals from GPS and Galileo during the trip to the moon. In this sense, we reached the important records. This is a beautiful picture of the lander, or better, the shadow of the lander just after the landing, the 2nd of March, with the Earth on the sky. And on the right, you can see a fantastic high-resolution picture taken by Lunar Recognized Orbiter that is orbiting around the moon and try to catch the lander on the surface. You can see in a small crater there is a small shadow that is our lander. This is another picture of the antenna deployed. And to explain you how much it's difficult to catch signals from the moon, I can show you the size of the Earth on the sky is almost 2 degrees on the sky, is more or less 4 times the moon we can see on our sky. And the orbits of satellites are really limited around 8 degrees around Earth. Then this, of course, makes a geometry quite not good to fix our position. Even the signals are coming 10,000 times less power than the signals we receive on Earth. Then it's quite a challenging mission that was completely successful. This is a screenshot of the telemetry of the signals. You see each signal is showed in this diagram with different colors according to the type of satellite, Galileo and GPS. And this is just an example of how much we were, if you like, enthusiasts of this activity, because it was not really, if you like, straightforward to have such experiment fully operated. But coming back to the dream, this is a magazine that my father was collecting in 1959, then largely before the man was going to the moon in 1969. And it's quite interesting to see how much the fantasy of the scientists and the technicians are already, if you like, showing a possible solution to go on the moon, even on Mars. That is the module we are designing to host astronauts on the moon. In particular, this module is a multi-purpose habitation module that will host not only astronauts to survive, to make experiment, to relax, to sleep during their mission, but even to host a lot of experiment. Then the opportunity to stay on the south pole of the moon is a unique opportunity for Italy, and we are sharing with NASA this development of this module. These are examples of the design. The last requirements we agreed with NASA are including wheels, as you can see. There is not a fixed dome, it's like a motorhome moved on the surface of the moon, since we have to stay 10 years on surface of the moon, and the exploration of the south pole will require to move from a site to another to explore at the best the opportunity of the experiment and the exploration itself. This is an example of usage of the module that can be attached to additional infrastructure. Here you can see the interior of the module that is, of course, based on first portion in which you can enter, exit from the module, that is, of course, not pressurized, to allow the extravehicular activity. To go on the moon is something that in the last years has been abandoned. You can see this graph is showing through 1966 from the first successful landing on the moon of Soviet Union lander up to our Blue Ghost mission in 2025. This showing, if you like, a gap that is the gray box in the middle, in which in some way the landing of rovers on the surface has not been considered a priority. Maybe most of the investment has been spent for Earth observation, for the International Space Station, and then in some way you can see in the last part of the graph there are new countries coming on the scene, including China, India, Japan, and we are, of course, as Italy and Europe, going to the moon again. But to go on the moon and to land in particular is not an easy task. This is the story of the crash of the landers. Even the Americans with Surveyor 2 were not able to land at the second attempt. Even recently, Luna 25, the Russian probes was failing the landing, and more recently, Into the Machine, the American commercial lander, was unfortunately landing not perfectly. You can maybe see on the web information. These are interesting pictures taken again each time there is a crash, the first thing to be done is to check the correct position on the moon surface. These are pictures taken by the orbit of the moon to identify the crash sites. Now we are going to compare the past and the future, making a comparison through pictures between Artemis and Apollo. You know, Artemis is a program to come back on the moon. Artemis on the history is the sister of Apollo. Then there is a link in this approach NASA is undertaking. And the idea is to have, for the return of the man on the moon, to have an astronaut, a woman astronaut, to stay on the moon surface for the first time. I think is an important scene of the story of the space that is really changing. Then this is a comparison of the rocket to go on the moon. You can see the Saturn V and the Space Launch System are almost the same in terms of size. Maybe the red colors are the biggest numbers. You can see the power is almost the same. The speed is almost the double because of the increase of technology on the engines. Even is interesting, the cost of the launch was in terms of billion at the developed time. Is something to be compared, but having in mind the completely different historical environment in which the Apollo mission has been developed. That, as you see, was really in the period of the Cold War, and the goal of the Apollo mission was not only to go on the moon for scientific reason, but even to win a race against the Soviet Union in terms of supremacy. These are the most important characteristics. No, Apollo was pioneering a very focused in cold strategy race. All the activity had been funded by public funds with an effort 100% from USA. There were even the approach to run a lot of risk. This was acceptable at that time, and all the technology was pushed at the maximum extent to satisfy the requirement. Today, Artemis is a long-term program. It's not just to go on the moon to put a flag, but really to stay, and then must be sustainable. And there is a progressive technology improvement, even because the objective is to go on the moon after the activity made on moon surface. Again, another important difference, NASA is not alone. There are more than 10 countries with the space agency that are cooperating, including Italian Space Agency. There is important contribution from private, then there is public-private synergy, and of course the risks are undertaken in a completely different manner. Today we cannot accept to have failures to put at risk humans during this activity. And then another characteristic is that we are learning while we are doing space adventure. This is also important because during the mission that will be for 10 years, we experiment technology that will evolve step by step. Interesting to see that facilities at NASA are the same. You can see on the right side are tests for the splashdown of the Orion spaceship. On the left there is Apollo. The infrastructure is the same. Even the splashdown is still the preferred solution. These are the two rockets on the launch pad with the moon inside on the background. Is something that is really iconic and remembering for the people with my age the year of the Apollo mission. And this is a comparison of the spaceship to the moon that are completely different. The service module has been developed by European Space Agency. This is even interesting to see that today the ship to go to the moon is a joint effort between USA and Europe. This is a comparison of the control center. That is one of the most important part of any space mission, including human space mission. You can see the development of technology. And this is a comparison of the engines of the Saturn V and the SLS. You can see that are quite big, the Apollo 1, with this a famous picture of von Braun standing in front of the engines designed by him. This is another infrastructure that is still used at NASA to test engines. And this is a comparison of the rockets and spaceships that are available in USA to cover the task of the Artemis mission. These are more wide view of all the spaceships for crewed missions from different countries. We can see the actually operational spaceship, but even the one that are under development. In particular, we can see Orel from Russia, that is has been announced to be developed to replace Soyuz, and of course the Starship that in terms of size is the most impressive. Now we ask to ourselves, okay, to go on space we have to push on innovation, but innovation is the only requirement, or we need something else? Because involving private commercial actors is of course an advantage in terms of time saving to develop technology, but there are a number of questions to be answered before to implement the correct approach. This is just a picture of the famous movie, maybe you know. This is an astronaut alone on Mars, and there are from each specific text, if you like, an embarrassing question that the software is asking to the astronauts. Your credit is over, the runtime error, compatibility, waiting for communication that is lost, the time is not correct, the artificial intelligence algorithm is under download. Then you can imagine when you are alone on space, the Earth is very far, you cannot bring with you all the expert you need, you have to be autonomous and safe. But let's go to the future we have in front of us. Then how we can design Moon and Mars habitation modules. There are, of course, three main, if you like, aspects to be considered: the environmental condition, the operational CONOPS, that are the definition a priori of what we have to do on surface on the Moon, on Mars, and the design in terms of constraints, requirements, what we need.
Sorry to disturb you, but can you hide the bar, because we are seeing the bar. If you hide it. Yes, thank you.
Okay.
Sorry to disturb you because.
No problem. Sorry for it. Then the design is the last aspect in which, of course, inside there is constraints, requirement, technology, opportunity. Then let's focus on environmental condition. There are 10 examples of environmental condition elements that you should consider when you design an habitation module. In red, the most important, thermal, atmosphere. Just to give you an idea, our lander, when was 1 week ago on the moon, was experiencing the high temperature during the day, reaching 120 Celsius degree, and in half an hour, when the sun was going down and the night of the moon was coming, the temperature was going down to minus 80 degrees. Then an excursion that imposes material and capacity to survive that are really demanding. Then there is the radiation. You know, as soon as we escape from our planet, we are exposed to radiation that are, of course, killing any form of life. And then the rest, of course, of the points are fundamental, but the last one, even I highlighted as red, are emergency scenarios. You have to, if you like, design your habitation considering contingency scenarios that, of course, are unavoidable. Then you can have interruption of energy, whatever communication, and you have to be ready, having a backup solution for each contingency scenario. The CONOPS, of course, are a mix of automation. In future, astronauts will work together with robots, with rovers that are moving together with them. Communication is fundamental. Communication means even locally in orbit, because there will be a station orbiting around the moon. And of course, to talk with Earth, with the experts at the control of the mission. Another important aspect is capability to design something that can be modified during the lifetime. In most of the case, we develop infrastructure that should survive for a number of years. And this means to have a lot of implication in terms of design. Then maybe you have to upgrade to add additional infrastructure. And of course, the CONOPS relies on science exploration objectives that are the reason for which we are going there to risk our life. Last and not least, the emergency contingency. Again, in the CONOPS, you should include even case in which something is going wrong. Design. This is very interesting because design up to now has been a sector in which, if you like, engineers have been involved, maybe only engineers, but we discovered that we need even other capability skill in doing such design. For example, shape, there are architectural and functional aspects to be undertaken, not only, if you like, the technicians, the engineers can say something. Robustness, reliability, availability, and safety, and even the material. In most of the cases, the idea is to use in situ resources. Then, since to bring mass on space means a lot of cost, each kilograms to be transported to the moon costs a fortune. Then, if you can use in situ resources like chemical material, ground material, whatever is available on site is cost saving and improving efficiency. Then to make experimentation on the moon, to be prepared to go after on Mars, means to keep in mind that there are some difference. Then in green, I highlighted something that is more or less in common on the two environments. Yellow are maybe similar but to be adapted. In red, you can see subjects that are completely different. In particular, for environmental conditions, the thermal control is fundamental. Radiation protection are in common for the two planets. Dust mitigation removal is something that must be developed in different way, but is still available on the moon. For example, the lander we have just used on the moon had some thermal problem because the radiators that are used to dissipate the high temperature was covered by regolite, that is this fine sense that is present on surface of the moon, and this is something that requires a lot of capability to remove the dust on the instrumentation. And then, of course, night survival. Night on the moon stands for 14 days, while on Mars is almost the same duration we have on our planet. For the CONOPS, the mobility is almost the same, apart the gravity that is different, 1/6 on the Moon and 1/3 on Mars. Extravehicular activity, there are clock, samples collection are activity that should be made in both cases. The habitation volumes, the duration is completely different. Then to go on Mars, we cannot assume to use the same infrastructure we have on the Moon, because the typical mission with astronauts on the Moon will stand for a couple of weeks, no more. While to go on Mars, you need something that requires to stay for maybe 6 months. Then the technology design, again, are of course based on robotic support, power generation. The in-situ resources are completely different, because on Mars we can find a lot of additional resources, and even the landing techniques are completely different. On Mars there is an atmosphere, and then you can use the resistance of the atmosphere where you are landing, while on the Moon you're falling down and you have to brake with the engines. Then it's completely different techniques that imply different strategy. Then the question is better to innovate or reuse what you already used that was, if you like, successful? There are a number of projects in the past, that is Skylab, the Russian Mir International Space Station, Tiangong, the Chinese space station, the current study that are taking the heritage of this experience, the multipurpose habitation model, lunar gateway, and then there is this new approach having a synergy with non-space civil engineering, architecture, and innovation. And the idea is to have a cross fertilization between space sector and non-space sectors. This is, if you like, something that has been discovered in the last decade as an important element. And then be inspired by natural structure. The nature across millennia of evolution is telling us how much is important to copy the natural infrastructure. These are examples of Chinese space station under construction. This is the gateway that is assumed to be put in orbit around the Moon. One of the first modules will be developed by Italy, by Thales Alenia Space in Turin. That is the one that is providing the majority of the pressurized model on the actual International Space Station. And this a nice picture may be produced by artificial intelligence, in which we can see a sort of preparation of highway on the Moon to allow an intensive activity to collect samples, to transport material, to support logistic activity. And the idea is even open to any solution for future technology. These are links that you can use to go to official documentation on ESA about the Artemis strategy. These are interesting links that I suggest you to spend time in going to visit these sites. Is an interesting competition ESA was undertaking for asking any possible actor to propose 3D printed habitat for Mars. These are the 3 winners. There are 3 different, completely different shapes of habitation modules that are, of course, just on paper, but based on rigid requirements that NASA was imposing. But even going back on the history, we can see examples of something that has been developed on Earth, maybe like in this case, for a very bad reason. This during the Second World War, a bunker that was really resistant to bombing. And this because the shape of the bunker was such that it was really rigid, is still there and not destroyed by any bomb. This another interesting example are simple walls that are being shaped with curves. because in this way, with the same material, with the same weight, you can have a more rigid. Then the idea is to have less material, more robustness. This is very interesting as an example. This is in South of England. These are examples of another website that you can visit, spacearchitect.org, in which they involved indeed new actors in this space investigation, that are architects that are working together with engineers and physicists to understand in which way the future habitation must be designed even for the interior. This, for example, is a quite interesting habitation that is assumed to be deployed on Mars surface. Since on Mars surface the temperature is very low, the idea is to use the ice like in North Pole, South Pole of our planet. It is inflatable infrastructure in which the ice is making a double, if you like, role, is making the structure very rigid. On the same time, water, the ice is protecting from the radiation. Then one of the most important risks we have on Mars, on the Moon, is the exposition to radiation. The ice and the water in particular are very useful in this case. These are other concepts. The concept of tensile structure. Why? Because the infrastructure we have to develop must be, if you like, limited in terms of use of material, but very resistant to, if you like, whatever is the reason for which the infrastructure is exposed. This is a bridge that has been designed by my father, Sergio Musmeci. If you go in Potenza, south of Italy, you can visit the bridge that you can see immediately. Even if you are not an expert on civil engineering, you can immediately identify a strange shape, and the results of this shape is exactly the concept of using the minimum quantity of material to have the best results. Then each square cube of material used for the bridge is developing the effort to sustain the road without giving just the weight. This is the idea. These are other example links in which you can take a look to this bridge. And this, of course, the 3D printed technology is something that is, of course, under consideration, because when you use in situ resource, the best is to bring a robot that is developing the habitation. This is an example of an habitation that has been developed totally with 3D printer. And these are examples of how much the shapes of natural elements like shells, sunflowers, but even a very big like galaxy are giving to us, if you like, a good idea in which way we can design with limited quantity of material the best resistance structure. Then what is the correct approach? Is really coming back to the initial picture, is to have, if you like, communication fully working as planned. We need inputs for deep learning. The astronauts working on the Moon, on Mars, should return even experience lesson learned. We have to monitor every day, every minute, the activity to correct eventually, if you like, a situation that could endanger the life of the astronauts, but even of the infrastructure. And then we have also to upgrade, as we do with our computers. We have to download improvement of software, improve the infrastructure. And then, of course, communication is essential locally, in orbit, but even with Earth. Then, in our horizon, we have maybe in the far future a number of habitations on Mars. And then the question is what we need to be prepared for such a scenario in which we can see a number of starship ready to land, to depart, and an entire city that has been developed on Mars surface. Of course, we need continuous nominal contingency service. We have to produce food, water. We have to produce power. We need communication, navigation, timing. And then, of course, the human skills we have to bring in our infrastructure directly by people, but even indirectly through, if you like, expert system, communication channels, artificial intelligence, engineers, physicists, informatics, but even scientists, geologists, sociologists, psychologists, and even economists and lawyers, because any activity made on space is regulated by international nation rules to avoid the pollution of our planets, of the moon, of Mars. There are rules in the international domains that must be, of course, respected. And of course, a lot of artificial intelligence that we know recently has been, if you like, developing a lot. We are learning how to, if you use at the best the artificial intelligence to do maintenance, emergency, even to make forecast. Then there is nothing better than artificial intelligence to maybe explore possible contingency scenario for environment that are not known at the best. And then, of course, a lot of machine like robot, drones, rovers. Then the question is if you are ready or not to prepare ourselves for the future. Now, this concludes my presentation, and I'm ready to answer questions you can have.
The microphone?
Yes, yes, it's still on.
Is it on?
Yes, yes.
Help me, please.
Watching on the vediamo se funziona.
Okay, so we've got a question that is, what is the difference between the new and the older space stations in terms of orbit?
Oh.
This is a question from Mr. Campisi, of course.
Okay, then the space station actually is the International Space Station is orbiting in around 400 kilometers altitude. The choice of this altitude is not made by chance, but is based on a compromise that is to have an orbit period that is 1 hour and a half, that allows with the inclination of the orbital plane to have to visit the Earth's surface quite frequently. And this allows the International Space Station to be used as an observatory for Earth. Then ISS is developed, is on space, but to look at the Earth. This is the concept. Even if has been, if you like, used to do a lot of experiment for deep space, like looking on the opposite direction and maybe collecting radiation to understand what it means to expose human body to difficult environment like almost zero gravity, radiations, and extravehicular activities. The Chinese space station is almost the same approach. Another reason to select such altitude is the capability of the actual rockets to bring logistic material and astronauts on board. Then if you select an orbit that is too high, this implies more power to bring everything in orbit. If you go down you have a problem in terms of velocity that should be adopted for remaining in orbit, and of course, as soon as you go down, you be in contact with the last layers of atmosphere that are quite dangerous. Then the 400 kilometers is a good compromise. I think all the different stations that will be developed will use such altitude. It's interesting against this question to compare the lunar gateway that is of course orbiting another body, the moon, that is small, and again the purpose of the gateway is not to observe the moon as such, as we do ISS, but to support the South Pole base. Then in the South Pole of the moon will be a permanent base of astronauts, lander, robot going up and down, and the orbit of the gateway is not circular, but is quite elliptical, making the pass over the South Pole longer to allow communication and transfer of logistic astronauts. Then each time you select an orbit, you have to do a number of trademarks of comparison to choose the best, but because it's a matter of, if you like, not only Newtonian law, but even of reason for which we are putting such infrastructure in orbit.
Okay, thanks a lot. Then we have another question. It's about the material used in the habitation module. That is, if the insulator silice aerogel, is it foreseen in among the materials, let's say the experimental materials which will be used for the habitation?
Yeah, the material is another important sector in which ISS has been used as a laboratory to test a number of different material. Today, there is a single module on ISS that is used in case of emergency. That is the only one that can ensure in case of solar storm to be very safe. The rest of the station is used day by day, but is not protected as this specific module. Then, just to give an example, in case of emergency of having peak of solar storms, even on board of the station, there are specific personal equipment to be used by the astronauts. One of the simplest idea is to use a sort of wearing a gilet with water inside, because as I said before, water is an important shield to protect the human body by radiation. Unfortunately, radiation is not the only problem on space. As we have seen before, temperatures are very extreme. When you are on space without atmosphere, the solar exposed part of a station is raising the temperature very much, reaching even 150 degrees Celsius, while the dark side on the shadow is very low. The material should be resistant for such extreme type of temperature between minimum and maximum, and this of course is fundamental to identify the best material. This is the reason for which the International Space Station, any spaceship has a double, if you like, functionality for thermal control. One is to warm the infrastructure in case of very low temperature. Another one are radiators that are used to dissipate the heating that is too much in case of exposition to the sun.
Please, Gabriele?
Another question.
No, there is the Scotland School.
Okay.
We are here. You are here to.
And then, yes, it's our turn. Sorry.
Please.
we have a question about how much it would cost to do all of this, like, you know, build the houses on Mars and get there and all of that.
And all the
Development as well, yeah.
Can you repeat how much?
How much would it cost to do the development to go to Mars and all of that?
Yeah, very, very difficult question. How much it costs to develop something? It depends on the concept we develop. It's clear that we cannot imagine to develop infrastructure as we do on Earth with a lot of, if you like, available resources, people working, and time available. On Mars, the best solution, even on the Moon is the same, is to have robotic infrastructure that will develop in advance the habitations in such way when the astronauts are there, they find directly the apartment ready to stand there. Then the cost is something that, of course, is driving in general the programs of exploration. You noted that since Artemis program has been announced, NASA postponed several times the Artemis 2 mission, the Artemis 3, because today, in comparison with Apollo programs, the budget is not infinite as was in the Cold War. Then the sustainability in terms of economy is fundamental. Then each time we spend money on space, we should, of course, have the endorsement of the different institutions, even if there are private companies ready to embark part of the cost, they look for a return. Then, just to make an example, there are companies that are developing communication and navigation service around the Moon. They invest money because they are thinking to recover the investment, selling the service to the different institutional private companies going there using their infrastructure services. Then the paradigm is completely different. It's not just to make a computation of the cost to understand how long it takes to develop it, but to progress step by step. Each step should be sustainable and justified by a mission objective.
Cool. We also have another question, Jared.
How long would it take to send messages to Mars and back? What's the way to get around that?
Sorry, but the voice comes to me very low. Can you repeat?
How long would it take to send messages to Mars and back?
How long?
Yes.
Yeah.
Now, to go to Mars, there is a fundamental law that is defined by Newton, for which orbits of Mars and Earth are not synchronized. Then there are a number of years in which you have to wait until there is the opposition Mars against our planet. This makes the trip very affordable in terms of time. The actual estimation are 6 months to go, 6 months to come back. And of course, you can imagine when you spend 6 months to go somewhere, you should stay for almost the same period on Mars. That is quite challenging to assume 1 year and a half of exposition to radiation of astronauts. Today, there is no, if you like, a technology solution available on the table. Then whatever will be the availability of Starship, of mega booster to bring material and astronauts on space, this is not the only need that we have. It's really a matter of, if you like, satisfying all the requirements. I believe that before to go with astronauts on Mars, we will see a lot of robots that are already working on Mars, but more sophisticated robots that should also, if you like, make experiments like a human like human activity, then to develop an habitation, to test the environment, to make measurements of the radiation, to test how much these infrastructure are ready, even in long term, because again, it's not matter of going there to put a flag on the ground, but it's really something to be made for a number of months. It's almost the same for the moon, with the big difference that to go on the moon requires a few days. Then you can even imagine to have an emergency mission to get back the astronauts in case of dangers, while on Mars this cannot be possible. Last point is the communication latency with Mars that imposes to have, if you like, capability in orbit to Mars and on surface of all the skill you need in case of contingency. While on the moon, the latency of the communication is almost 3 seconds to go to come back for the voice, for the communication, and this allows, if you like, support from Earth in case of need.
Brilliant, thank you.
Thank you.
Yeah, welcome.
Another question, Elia? Elia wanted to ask you this.
What are the conditions of life on Mars?
The condition?
Of life on Mars.
Good.
Good question.
Good question.
It is a good question.
You know, there are theories that are telling us that Mars was, if you like, more favorable to life in the past, and even for Venus there is the same idea, and there are actually a number of robots that are working, watching to specific sign of past life on Mars. It's difficult to make a judgment of the past life. First of all, when you look for something, you make an assumption. No? You look for life as we know the life. This, of course, if you like, impossible to compare life in different way. In addition, the surface on Mars is completely, if you like, exposed to radiation, because the atmosphere is really teeny. Is 6 millibar the pressure on surface, that you cannot have liquid water on surface. Then the only, since we know from the scientists that water is one of the most important conditions to have life, because on Earth we have a clear, if you like, seen that water has been one of the accelerator of the life development and evolution. The only hypothesis that in the past liquid water was present on Mars surface, and this imposed to have a different atmosphere that maybe has been evaporated in the course of the billion of years. Then the question is still open. There are in particular missions that are planned in the near future that are named Mars Sample Return, because the only way to make an investigation really effective is to collect samples on Mars without polluting it, of course, bring back to the Earth laboratory, and to make very deep analysis to investigate on the content of these rocks to discover something. You can imagine how much is complex, not only to go on Mars to collect samples, maybe it's the simplest part of the mission, and the difficult part is to bring back on Earth without polluting, and maybe to discover that the life is the same life we bring on Mars, and we make a fundamental mistake.
Okay, thanks a lot. Any questions from Scotland?
I don't think we have any more questions.
Okay, so we can go on with Gabriele. Gabriele has got another question for you.
Can you tell us about your career?
You want to know a little bit about my career?
Yeah.
Yes, please.
Okay. I can tell you, when I was 9, the man was landing on the moon for the first time in 1969. And of course, I was dreaming since this event to not to be an astronaut, but to look for the space as an astronomer. Then my career was at the beginning as an astronomer. I was following physics in the university, and my idea was to, as my job, to become an astronomer. Unfortunately, is a kind of job that is not easy, because science requires investment from each country. Italy at that time was really poor in terms of investment on science. Then I was obliged to change a little bit my career at the university, and then I added specific subject like informatics. At the time there were expert system, that is, if you like, the grandfather of intelligence, artificial intelligence. And because I had the perception that informatics in that year, I was thinking 1980, was very well developed, and there were a lot of jobs. And I made the right choice, because as soon as I had the degree on physics, with such complementary capability in geophysics, astronomy, but even informatics, I was able to find a job immediately, even to select the job. And this is an important, if you like, message I would like to pass to you. Your dream should become, you remain alive. You should keep in your mind your initial dream without abandoning it, even if your life will evolve in such way that you cannot, if you like, know in advance. But to keep alive the dream is fundamental. At the end, I was working for a very specific company that at that time was developing air traffic control system. And then I was developing software for air traffic control. That is a quite interesting subject. I was learning a lot on air traffic control, because there is safety inside, there is communication with airplanes. You have to learn all the rules in which ICAO is managing the flights around the planet. Is a subject that you can, if you like, investigate for your entire life. But at the end, I was going to my boss, I was saying, look, I'm very happy to work for your company, but do you have something related to space? And I was quite lucky because they were receiving from a space company in Italy a request for an expert to compute some software, to develop some software for space station, for the space shuttle. At that time, there were the space shuttle mission. And this is the reason for which I passed from air traffic control to space. Then, as you can see, your career can be, if you like, changed depending on your, if you like, interest. But you should move. You can press your colleagues, your boss, to improve the quality of the work, because when you do the job that you like very much, you don't count the hours of work, you are very satisfied. And this is a benefit even for the company for which you work. Now I'm close to become 67, that is the year to be retired, but I can tell you that will continue to work on space because, in particular, I have an activity with my daughter that is having a degree on historical cultural heritage, and we are making activity of education in terms of making the bridge between history of cultural heritage and space adventure that are something apparently quite different, but at the end are very similar because there is the man in the middle. Then, as you can see, everything is at the end of the loop is coming back. Then the difference of the, if you like, in your case, that now with the internet, with the very quick development of technology, the number of opportunities you have in front of us maybe are too much. Maybe you can become confused in understanding what is your best position in terms of skill development. Then my suggestion is to keep the dream in your back of your brain, to accept even compromises, and that is a good compromise between a job opportunity and your dream, but at the end you will find your way.
Okay, allora, Yasser wanted to ask you something more. Go.
What diploma did you get before university?
Before the university, you mean?
Yes.
Scientific diploma in scientific lyceum. At that time, I was still dreaming to become an astronomer. Then, at the last year on the examination, I made a thesis on Mars observation, because at that time, one of the first lander was exploring Mars. It was named Viking. There were a couple of lander from NASA, Viking 1 and Viking 2, and I remember that I passed the entire nights to develop an entire Mars surface model using maps that were available on paper. At that time, everything was on paper, of Mars surface. This was really appreciated by the examiners, but you have to know that after that, the laboratory of planetary geology in University of Rome was asking to use my model to make experimentation on their work. Then I was very happy to see that, if you like, something made during the night was really useful for scientists.
So you were ahead. 100 years, 200 years ahead. Alberto here has got another question for you.
I was wondering,
Yes.
what type of jobs could I get if I studied this specific sector of astronomy?
Which kind of charts? Huh?
Yeah, which
Yes,
type of
jobs.
Okay. This is a really good question, because normally we associate STEM activity to space, no? Like is the only, if you like, a kind of skill you have to work on space. But it's not true, because in the Italian Space Agency, for example, as in other agency in the world, there are different capability required. I'm working every day with the lawyers that are experts on international laws. Then to develop a station on the moon, you don't need just engineer, physicists, chemists, but you need even people that are regulating the approach of the experimentation, respecting international organization rules, even to make agreement between different governmental agencies is something that requires a lot of knowledge. Then international law is another sector. Of course, the medical sector is fundamental, because each time you have astronauts, we have even experts on Italian Space Agency that are taking care of the health of astronauts, even, of course, as the last sociologist, because to live in a very segregated area for a long time, you need, if you like, to manage the psychological dimension of human behavior. Then you can look for a number of movies on science fiction in which these aspects are well represented. Then, as you can see, space is really like Earth, a multidisciplinary environment. The only difference is that you cannot bring everything with you, and of course you cannot have water, air to your disposition. Then everything is more complex, but the needs are exactly the same. We need all the different skills we have on Earth on space. Another example is AI, artificial intelligence. This is another sector that, as I was, if you like, using in my career the informatics, and now artificial intelligence is something that is transversal to any activity. Then will be used for not only for space but all the sectors, especially for space, because to have something like the collection of the different expertise collect on a single computer, talking with an astronaut in isolation will be the difference. This is, of course, one of the most important aspects of artificial intelligence. In addition, there is the capability to predict something that is not been observed in advance. Then the predictive capability of AI is also another important element. They can, if you like, identify scenarios, contingency scenarios that maybe has not been never observed in our past experience, but we can afford thanks to this vision.
Again, Alberto.
What type of artificial intelligence do you use? Is it like a custom one, or is it like based on models that already exist?
But we are in Italia Space Agency now having internal courses to pass such skill to all the different people working in agency. It is an important thing. I mean, we discover even in public administration that AI is something very interesting. We discovered that there are, of course, drawbacks in using it. We use, of course, according to the objective neural network to make analysis of evolution on the scientific domain, but even deep learning software to develop, if you like, possible solutions. But maybe an interesting example, before to make this experiment on the moon with GPS and Galileo, I was asking to one of the most important AI app, this ChatGPT. I was making a very simple question. Is possible to use GPS and Galileo on the moon? I can tell you that the answer was no. It's not possible, because GPS and Galileo has been designed to be used on Earth. And then a number of reasons for which we cannot use GPS and Galileo on the moon. And then I was answering to ChatGPT, look, we are doing a mission on the moon to make such experiment. Then maybe we can catch the signals even if very low in power. And then the ChatGPT was answering, thank you for this information. And then was maybe looking for deep analysis on the web, providing me some examples, including my mission. Then I made the same exercise after the mission, and now ChatGPT has learned that Lugre, that is the name of the experiment we made, is proving the use of GPS and Galileo signals on the moon. With a number of limitations, of course, we need specific GPS around the moon to be safe, very safe. But it's quite interesting to see that AI today is still on a very beginning phase. You should not trust 100% on the information we got. And in some way, I'm proud that we were far than the artificial intelligence in doing experiments on the moon. I see an answer from Derek, please.
Yeah, we have another question. What was the most memorable thing from your job?
Let's say when I was in Houston for the space shuttle mission, I was touching with my hands a dream, because I was a child when Apollo mission was there. I was working for a number of months in control center in Houston, that is the same user for Apollo mission. This was for me a dream. Really, in such a period, I remember I was not counting the hours of work. I was even covering shift during the night. Maybe at that time, if somebody was asking me to work for free, I was even available to work for free, just in exchange of food and a bed to sleep. Then this, if you like, the extreme case when you do a job that is not a job, but is really what you like. And you don't see the difference between the hours of your work and the rest of the day. You are still thinking to do better your job because you are happy to do it. And I have to say that after almost 30 years, during this last mission, that it was completely different, because I was at the Goddard Space Center with NASA, working for a payload that is something that is robotic without astronauts on board, completely different, a mission that is simplest, if you like, experimental. But I was the oldest one in the control center, and I was looking to the young people around me, and I seen the same light on days when they were very happy to work. Then satisfaction on job is a fundamental objective, because makes people happy while they are working.
Okay. If we were interested in coming to your space agency, what are the possible activities aimed at the students?
Okay, on the Italian Space Agency in Rome, we have on the website, I think I passed it to Professor Ciampini, there is a link to reserve a visit. I think now the reservations are quite fully booked until a certain period, but I suggest you to visit frequently the site. Eventually I will pass you again the link. This is the normal way in which schools are allowed to visit our premises. Normally there are colleagues of communication to welcome students and to show something that we have exposed permanently at the Italian Space Agency building. There are models to be seen. In particular, I'm working now to develop a model of the lander we have used to go on the moon. Then in more or less in 1 month, we will have even this additional model. And normally they call me or other colleagues to support the visit, to make maybe to answer to questions, to explain a little bit. This is the simplest way. Then we have a special open days of our agency that is normally at the end of September every year. That is the night of European research, in which you can enter in our premises. Is open to everybody, and during this event that is normally starting in the afternoon, ending more or less midnight, we have a lot of activity. We have a telescope to observe the sky. I'm personally involved with the rest of my colleagues in developing activity for everybody, starting from children to students of university. There are laboratory. These are unique opportunity. If you can organize a visit for this specific date, will be the best. There is also another opportunity that is close to Rome. Frascati is a village not so far from our premises, in which there is the European Space Agency building named ESRIN. Is one of the facility of European Space Agency that is in Italy. They are focused on Earth observation, but every year they organize the school days. They're normally in period of April, if I remember well. There are, if I remember well, an entire week devoted to accommodate the visit of people coming from all the country. Then, especially Italy, there are buses coming from everywhere from Italy. And I'm even involved in such activity. I can tell you it's quite interesting, because ESA is well prepared in making education and awareness of their activity. And again, it's a mix of experimentation. Students are really engaged to do something practical, to do something that is linked to different activity like exploration, Earth observation. This is really a unique opportunity.
Non c'è una domanda specifica.
Okay, allora we've got a question from Davide.
From Davide, staff here at the what kind of food did you eat? Did you see when you was in the space? Yes, exactly.
The food for the astronauts, you ask, no? Right?
Yes,
okay.
Yes.
This is another field referring to the previous question, no? Another complete field of skill that we have to develop. We pass from very basic nutrients for astronauts during the initial phase of space exploration. Today we have on board of the space station food that are prepared customized astronauts per astronauts, because you know on the International Space Station there are astronauts that are coming from different countries with different cultures, with different willingness to have a food. In addition, there are shifts. Then while maybe some astronauts are sleeping, others are working, the food should be continuously available. There is a kitchen with a microwave. And normally food must be, if you like, frequently bring to international space stations for refreshment of the logistic, including experiment, even food. One of our astronauts that was spending months on the International Space Station, while he was connected with the school, in front of this question, was saying, no, the food is not so bad, I miss a pizza. as an Italian astronaut was asking a pizza, but this was just a joke to say something unbelievable. Then you have to know that the next cargo ship bringing food to International Space Station was bringing pizza for everybody. Of course, the pizza was not so good, but you can eat whatever you like on the International Space Station. Of course, when you go on Moon, on Mars, there are different problems. You cannot bring food for 6 months of mission on Mars. Even on the Moon, it's not so easy to bring water and food for the full period. Then what scientists are looking are production of food. Then this another technological development that is very interesting. There are Italian startups that are developing infrastructure that are able to grow plants using a minimum quantity of water to have a very quick growing of the plant that can be used as food. Then this is a sector that is per se an area in which a number of technology and skill are required. If you go back at the very beginning of the the astronauts going on space, there were a very big question marks because at the very beginning nobody was sure that a human can eat food in absence of gravity. And this is something that is not trivial. Then the first astronauts, Russian astronauts, was asked to eat something during the first mission to check if he was able to eat, to digest something very simple. You can imagine such experiment was putting at risk the astronauts, but they discovered that our human body is so fantastic that you can even digest in absence of gravity something. Then this is also true for water. Of course, you have to avoid the pollution of the instruments with the food, with water. But apart this problem is just a matter of sustainability and the mass of resources you have to bring with you.
I have got a question now. What about sustainability that you have just mentioned? In general about the space, because we know that there is lots of space rubbish, because when satellites are out of order and so on, so also we have also heard about space pollution. What about it?
Good question. For example, if you look to Starlink, you have to know that I'm part of my job, I continue to use the telescope to observe the sky. I can tell you that during the last years, each time I make a picture of the sky, there is a Starlink passing and degrading my picture. Even astronomers are not happy. In general, the number of satellites, especially on the low orbit, because the low orbit are the one used for such mega constellations like Starlink, but not only, are the most exposed to produce debris. And this, of course, because satellites are orbiting very low, and when they finish their lifetime, normally they fall on Earth. They are designed to be destroyed at the maximum extent during the impact of the high-level atmosphere. But in case there is something wrong, part of these debris are falling on Earth. In addition, debris are produced by very old satellites that have been put in orbit 30, 40 years ago, when there were no rules, international rules, to avoid the pollution of the orbit around the Earth. And then there are cases in which satellites can produce dangers to other satellites, even to International Space Station. And we have to remember that now there is an international rule that is adopted by the majority of the space agencies in the world to design since the beginning a satellite, including its capability to be deorbited in a safe mode. Then each time is like when you buy a new car, you buy even the disposal of the car, and this approach must be undertaken for space. The more we go on space, the more we understand that we need common rules. The debris is not just a matter of environmental pollution, but is really a matter of safety. When you got a debris on a window of cupola on the International Space Station, this will endanger the entire astronaut's life, because it's like a gun that is firing against the window. Then today in Italy we have developed a special dedicated telescope that is assumed to be installed in Sicily. The purpose of this big telescope is to observe continuously the sky to detect debris, even to identify asteroids that are coming very soon, very close to Earth, to detect them in advance, to take some decision. Like recently we were learning from the TV that there were a big asteroids coming at the distance of the moon. Then in general, debris produced by humans and natural body are something that is, if you like, a risk and must be monitored to avoid the collisions. And of course, there are countries that are not respecting these international rules. Like, for example, I remember some years ago, China made an experiment to fire on purpose on a target satellite to check the capability to destroy satellites. Then, unfortunately, there are even satellites that are used not for science but even for defense, and these are a strategic dimension that, of course, unfortunately implies even decisions that are unilateral and not according to international rules.
Nicola have got a question about everyday life in space.
Okay, so basically, after you eat, you have to go to the bathroom. Okay, and how does the bathroom works in space?
We were curious about it.
Yeah, I mean, it depends, because if you are on habitation modules, there are toilets that are well developed since decades of years, and now there are, of course, just a problem of privacy, because of course the space is not so big. Then when you use the toilet, is a little bit embarrassing, because maybe you have in front of you somebody else. But there are technologies that are made to, if you like, allow you to use a toilet as you use on our planet, even if there is no gravity. There is a pressure that is collecting everything. And in addition, I can tell you something, that apart the toilet itself, the urine of the astronauts are reused to extract water. That is an important capability. Then everything on the space station is reused. This is another lesson learned for our planet. When you go outside our planet, we discover how much is precious our resources like water, food. And then a lot of technology that has been developed in space, we can reuse on Earth, in having maybe reuse of water on an area that are desertic, in which water is really something difficult. If we look to the past, astronauts for the Apollo mission was not having any toilet. They were using solution like the baby today. And of course, you can imagine the mission was just standing for a week. Then was something that not allowing them for the space available to have a toilet. Even to make, for example, a shower is not so simple. On the Skylab was experimented the first shower in zero gravity. Today, most of the solutions are based on something that is more based on cleaning towels to use directly by the astronauts in their body. Then the shower itself is something that is too complex to feel challenging to be used. But of course, if you go on Mars, on the Moon, maybe we need even a real toilet and shower.
We wanted to ask you, our students in Scotland, if among you is there anyone inclined in working in the careers that Dr. Musmeci has told us, has displayed? Present here today or someone you know?
Sorry, could you repeat the question, please?
Yes, is there anyone among you that is the group that is at present listening to us, or some of your friends that you know are dreaming of working in the field of space, in the careers that Dr. Musmeci has told us and has explained are possible in your future careers?
Jenny, you want to work in space?
Yeah, I think Dar here would love to work in space. I mean, I wouldn't be against working in space.
In which type of career do you see in the future?
Engineers.
So something like Dr. Musmeci, let's say something which fits his career. Okay, so Dr. Musmeci, so you've got a future possible co-worker, colleague.
Good. I can assure you that to work on space, you don't need to go on space. Then for each astronaut in space, there are thousands of people on Earth working for them. Just to give you an idea, the lander mission we made just 1 month ago was engaging me for 5 years. 5 years of work to have 2 months of mission on the moon. Then there is a huge quantity of work to prepare a mission. And even now that we have all the data collected, we have terabytes of data to be analyzed. We have entire university engaged in analyzing the data, having PhD, having students working on this data. Then, if you like, the moment in which the astronauts is taking an adventure is just the peak of something that is prepared in advance and produce a lot of data to be analyzed after. Then to work on space, you can keep your feet on Earth.
Thanks.
But of course, if you like to be an astronaut, why not?
Okay, so and among our students, anyone interested in a future career? Anyone?
Maybe if you ask Harriet to become an astronaut, because I can understand it's not so simple to go on space, to risk your life. I think in the future with the virtual reality, you can, if you like, have the same experience as an astronaut with the new technology that is coming. Then maybe the future will be more robots on space, less astronauts, because impose a lot of complexity for the safe, and then maybe you can control and command robots from Earth even with latency, but making experimentation or laboratory in which you can really live your experience like to be on Mars.
And what about your English skills? Since I am a teacher of English, I'm interested in letting my students know how important English may be in their lives.
Good. My English is very bad, even my Italian, because I'm speaking Roman slang. Then
You are great because we were, let's say, fascinated by your skill in speaking, in engaging. My students, in fact, were really struck by you. Because we have had so many online meetings. These are the first ones in English, but also Mr. Campisi said that you have got such a passion that you want to share. So that is your big desire to share, that you can catch our attention and keep it alive all around the meeting. So
you appreciate. Now, in general, I was studying English at school, but when I was young, English at school was very limited in terms of hours. Then exiting from the, if you like, a basic school to Lyceum, I was not really able to speak English. And then I was obliged to learn on job English. Reading documentation that is in English. All the documentation available on space sector are mainly in English. Unfortunately, I'm not able to read Russian or Chinese, but maybe in the future you are obliged even to learn Chinese and other languages. Even if there is translators, then maybe with the online translators you can bypass the problems. But to speak direct with people is something completely different. And even with my bad English, I was really enjoying the last control center work with a lot of people that are coming from different countries, because in USA you can meet even people with different culture, and then each one is speaking English in different way with a little bit accent from different countries. Even from Scotland, there were one of the people working for NASA was coming from Scotland, and I immediately recognized the accent from Scotland in the English. Then you have to learn and enlarge the English, let's say, more to able to catch different slangs rather than to be very precise on speaking and learning the grammar.
And have you ever had experiences abroad, or mainly you hosted people in Rome, hosted colleagues in Rome?
In particular, myself, I was spending 6 years in Belgium, in Brussels, because I've been engaged for European Commission, European Space Agency at the very beginning for Galileo mission. At that time, Galileo was not approved by European Parliament, and they were working to prepare the definition of the system to get the authorization of the Parliament to invest the money. Then again, it was an international environment in which there were people coming from different countries of Europe. We were even traveling a lot. Travel is another important element you have to do, because you know different culture, people, way to make the same jobs in different way. We were, for example, at the very beginning traveling even in China, in South America, in Africa, making dissemination of the information of Galileo to understand how much the Galileo service can be used by each country to develop their capability in terms of transport, of safety, because of course you can imagine navigation means to have safer airplanes landing, trains that are moving automatic robot moving drones. Then satellite navigation is transversal to a lot of economies, and even if a country is not having its own system in orbit, they can use the signals, and this is something that you can, if you like, teach to people or to develop a very basic application on your smartphone using your position, for example. This is something that can be made by everyone able to work a little bit with the software of Android.
Okay, so to the students in Scotland, if you enjoyed this meeting,
Yeah, we did enjoy this meeting. Really interesting. Find out
thanks
how.
a lot for your patience because it was quite long, so we know, we are aware of that.
It's been a fun time.
Thank you. And to Dr. Musmeci, a huge thank you because you were amazing.
Thank
So,
you. I'm very happy. I hope to see you soon. And now it's your turn to prepare the space for the future. I will look from my sofa your development when I will be retired.
Thanks a lot and bye-bye. Enjoy your day, everyone. Bye-bye, students.
Bye.
Bye. Thank you so much. Bye. Bye.